Now I want to finish off the serverless stuff today, and I'll also talk a little bit about the specification. Hopefully you've had a chance to read through it before this, but I'll talk through it anyway. So, but I'll begin looking at the finishing off the slides that I started on the last day. So we are talking about this Cognito service, which is the AWS service for managing essentially user accounts. It is serverless as well. And it's the last of the serverless services that we're going to look at under this heading anyway, although I'll come back to some other services later on, which could also be categorized as serverless, even though they predate that term as such. So it comes under kind of it comes under state management, but in particular, it's focused on user account management. And it has all of the stuff that you would associate with user account management. Now, technically behind the scenes, there are two types of resources that you can create when you're using this Cognito service. The one that we're going to focus on are user pools, but there is this notion of identity pools as well, which I briefly talked about the last day, but we're going to skip by them really. And so if I fast forward to here, this is your kind of typical serverless architecture, which includes authentication. And it is that you have two separate APIs. You don't have to, but it's a good design to do so, where one of the APIs, this one up here in my case, is concerned with the whole user management side of things and user authentication. So when a user registers and logs in and all of that, they are communicating with this API here. And then when the user wants to access the application's functionality, then they go via this route down here. But in order to communicate with the services or with the functionality that's down here, they may need a token, a JWT token, in order to access them. And that token is provided by the functionality up here. So it's just two separate API instances, if you like, and there's lots of lambdas at play here. So in the case of the authentication part, which is really where we're kind of focused on today, we've got an understanding of all of this stuff down here from the lab that you're working on this week. But in a way, what's going on up here is quite similar, except that we're not talking to a database or other lambdas over here. We're actually talking to this Cognito service. But what the first lab that I will give you after the midterm break now will essentially be to implement this architecture that you're looking at here. And what you will notice is that we have a whole bunch of lambdas here, each of which is concerned with one aspect of user authentication. So there'll be a lambda that handles registration, a lambda that handles login, another lambda that handles logout, and so on and so forth. Okay. So in terms of coding then, how do I create that architecture on the previous screen, and in particular the top part of it? Well, the first thing I want to do is create a user pool, NCDK, and I'm showing you the code for it here. It's all fairly understandable stuff, I think. There are obviously lots of other attributes and settings that I can make on my user pool, but I'm showing you the kind of the minimum here. So this property here, you're essentially saying that, what are we saying? That emails or usernames can be used as aliases for logging in. This second property sets self sign up verif enabled means that we're allowing the user to verify their registration. And I'll show you what I mean by that. The alternative is that maybe some third party, maybe an administrator, is the person that's responsible for verifying a registration. So there's kind of two steps to registering: filling out the registration form and then confirming your registration. The only reason I've included this here, the removal policy, is such that when I destroy the stack that contains this entry, then the Cognito pool gets destroyed as well. That's fine when you're in development mode, but obviously it wouldn't be a good idea when you're in production mode. You may want to tear down the stack, but leave the user pool still there, because there can be multiple applications potentially using the same user pool instance, and that is often the case. But anyway, we are deciding to set the removal policy to such that it destroys the pool when it's when the stack is destroyed. The second part here is, as I just mentioned there, you could have a number of applications that are using the same user pool. And the way Cognito is designed, each application has to have its own client for accessing the pool. That's just the way they designed it. I guess it's good separation of concerns. So what I'm doing down here is creating a client for the purpose of communicating with the pool. And this client will be used by any Lambda that needs to interact with my user pool. And the settings, auto flow set to username, password. Well, okay, we're just going to follow these kind of standard authentication flow, which is register, confirm registration, and then log in using a password. They do allow you to define a custom authentication flow, which we won't do. And there is another authentication flow, something called secure remote password protocol, which we won't look at, but it's an alternative to your kind of standard authentication flow that we'd be familiar with. So we're using the standard one anyway, and we do have to declare what authentication flow we're using. So that's fine. What I'm showing you down here then is, once I've got this code in my CDK stack, when I deploy the stack, then I will see evidence of the user pool. So I've already deployed a stack for myself, and the stack is essentially an implementation of this one here. Okay. So if we just very quickly go to my AWS account. So there's my single stack. It's one stack, but if I go into API Gateway, you can see I've got two web APIs, if you like. This one, based on the name, looks like it's the one. This is the one that is at the bottom of my screenshot, at the bottom of essentially this one here, just going by the name. And the other one looks like it's the one that handles the authentication side of things. So it is two separate API gateway instances. And if I go into Cognito, then I'd expect to see my user pool created. And so there's one user pool, and here's my user pool. And if I go into it, currently there are no users registered on this pool. Yeah. So that's fine. Now, the detail of my two web APIs. So this is the breakdown that I'm going to have for my authentication API. So there's a couple of endpoints based on the names. This one here looks like the login endpoint. This one way down here looks like the sign up endpoint. This one here is the confirmation of registration. And there's also a sign out endpoint. And most of them, well, a lot of them are posts, obviously, post endpoints. And then on the right, then I have my application, which we're not too interested in. It just has two endpoints. And just to illustrate a public and a protected route within your application. So that's what you see on the right. Down in the bottom right of the screen, then I'm showing you the various lambdas that I need to support all of this. So these are the lambdas that will be backing all of the stuff over here. These two lambdas down here are the backend for this part of the API, this part of the application, sorry, the functionality side of it. And the last lambda called authorizer, I've just called it the authorizer lambda. That's the one, if I just go back, that's this one here. And what its role will be is when a request comes in to the, I'm distinguishing these, I'm calling this the application API and this the authentication API, just for clarity. Okay. So when a request comes into the application API, and if that request is to try and access one of my protected routes, then the request will have to include a JWT token, which would have been issued when the user logged in. And that JWT token needs to be validated. Okay. And that validation is going to be carried out by this Lambda here. And it will actually talk to Cognito as part of that validation. So I should really have a connection there. So now, again, I say all of this you will put together in the next lab, which is the first one after the midterm break. But I'll step through it anyway, in overview terms. So I want to sign up to this application. And so I'm just showing you here a screenshot from my Postman. So it's a post request to the particular URL. If I just go to, well, let's say here, it's a post request to a particular URL. The URL here will be the URL of the top gateway in my screenshot that I have illustrating the overall design of this, plus the path part at the end. And these are the credentials, these are the body of the request. So I have to provide a username, a password, and an email address. Now, I didn't really have to, but I've anonymized the email address, but it's going to be my my Gmail address. By the way, by default, Cognito applies certain rules on the password requirements. So I think there has to be, there's a minimum link to the password. It forces you by default to have at least one non-alphanumeric character, one numeric character, one uppercase character, and the rest of them is up to you. So if you try and give it something that violates any of those default constraints, and you can define additional constraints on the password if you want to. So if you want to make it the minimum length something bigger or whatever, you can do that. And you would do that when you declare the Cognito, when you declare the user pool in your CDK stack. So I just took the default anyway. So when we send this request, then we're going to get back a response, something like this. So I can actually just do that maybe. If I just go over to VS Code first. So I deployed this stack there just before the lecture. And in the response that came back from the deploy let's see, you know, there are, again, kind of confirmation, there are two API gateways. So this is the URL for the API gateway associated with the app API, whereas this URL is the URL for the what it calls the authentication, the auth service. Okay, so just don't mix them up when you are going through this lab yourselves. And so I've taken those two URLs and I've gone over to my Postman and I've created a collection for myself for convenience. So here's my Cognito collection that I created for myself, and I've set up some variables. I've got an auth URL, and so I set that to whatever URL was provided by the CDK. And I've got my app URL. So I've already set those two up. We don't need token for now. We'll come back to that in a second. And so here's the sign up request within that collection. And you can see I'm using the, let's see here. Yeah, you can see I'm using one of my collection variables, and I'm tagging on the path to the default to the URL. This is the path for signing up according to my code. I haven't shown you the code, but that's okay for now. Here's my details that I'm registering under. And so if I send a request, so it looks like I'm getting back a 200 response. So that's good. So if I flip over now to Cognito and look at the user pool, I do a refresh. So there's my user, but notice the user is not, how does it put it? It's unconfirmed. So we need to go through the confirmation of registration step before this user can actually log in. Now, given how I've defined my user pool, if I go back to here, a lot of jumping around now, but if I go back to here, I decided to use self sign up enabled. So the user is allowed to confirm their own registration. And so the way that works in this case is Cognito, well, AWS really will send an email to the email address that I provided with a code. And I need to use that code then during the confirmation step. So the email address that I provided in my registration was my Gmail address. So if I look at my Gmail account, here's the email here. And so this is the code that I need to use in the confirmation step. So if I copy that, and if I now go, I'll just do the confirmation first, and then we'll have a look at the code. That's the Lambda code that's working behind the scenes here. Here's my confirmation request. So again, it's a post request to the auth URL with this particular path within that API. And in the confirmation step, I need to provide my username and the code that was given to me. So I need to change this to the code that was given to me and send that. And it looks like it was successful. And if I go back to Cognito now, and do a manual refresh. And so my user is now confirmed, so that they can now log in. Now, in terms of, so I issued two requests there. I issued a registration request and a confirmation of registration request. So what's the Lambda code behind the scenes? So if I go back first to here again, so the registration request was a post request with a body, and that was based on the API configuration. And I'm not showing you the API configuration, but it's the exact same as the way you would set up an API gateway as you're doing in this week's lab. Okay, so it's going to route the request to a particular Lambda. So all we need to really look at is the Lambda. And this is the Lambda that's invoked when user tries to sign up or register. So in the initialization part of this Lambda, I need to create an instance of essentially a Cognito client. Okay, so that's, I'm leaving out the import, but there's obviously an import that includes this client and specify the region. So this is similar to creating a DynamoDB client. There's not as much configuration though of the Cognito client. So that's fine. And here's the handler. And in the handler, I'm extracting the body. Now, what I didn't show you, I don't think I showed you anyway, is in general, right? When you're sending a post request through API gateway and forward onto your Lambda, the body, sorry, the body of the post request will be included in the event object that's passed on to your Lambda. And that's what I'm doing here. I'm going event.body. But if you actually looked at the body of the event object, what it will contain is a stringified version of the HTTP request body. So what's he talking about there? What he's saying is, just in the case of this, for example, this was a post request. And this was the body of the post request. Okay, it's in JSON form here, but this is on the client side. This is sent across the wire to my API gateway, but it's an API gateway passes it on to my Lambda, but it's not presented to the Lambda as a JSON structure. It's actually presented as a stringified version of this JSON structure. That means my Lambda needs to convert it from a string back to a JSON structure. In other words, it needs to parse the string so that it can be presented to my Lambda as a JSON object. And you can confirm that yourselves if you do a console log of the event inside in any Lambda that is at the receipt of a post request, then you will see that the body of the event, which contains the body of the post, will actually be a string rather than a JSON object. It'll be a stringified version of a JSON object. Right, that's why I am doing JSON.parse of the event.object. If I just assign event.object over here, this assignment statement won't work, because on the left of this assignment statement, I'm assuming that what's to the right is actually a JSON structure, and it won't be. It'll just be a string. But if I do JSON.parse it, then it is. Okay, that was a bit long-winded. Right, so I'm just extracting from the JSON object my username, email, and password. Now, the way this Cognito client works, it's actually designed very similar to the way the DynamoDB client is designed, and that was intentional on the parts of the AWS people so that it's easy for us developers to use, because there are multiple clients that we need to use depending on what service we want to talk to, whether we want to talk to DynamoDB or to talk to Cognito or talk to SQS, which we will be doing later on, or talk to SNS, which we will be doing later on. So that all of these services have their own clients, and if the clients are all designed differently, then it's just a bit of a headache, really. So fortunately, many of the clients, not all, but many of the clients are designed around the same sort of patterns, which is this, and the pattern is, and you're familiar with this now from DynamoDB, the pattern is that your Lambda creates a command object and you send that command object to the particular client, which then passes it on, which, passes on the equivalent request to the in-service in this case being Cognito. So with that in mind, the command that we want to send to Cognito is a sign-up command. And so first of all, I need to construct the properties of that sign-up command, and that's what I'm doing here. So we would need, so this type is, we'd obviously need to know the structure of that type, but I'm giving it to you anyway. So my sign-up command input, that's essentially the configuration for my sign-up command. It's going to be an object. And some of the properties are, as you might expect, I'm passing on the username that I have extracted up here. I'm passing on the password that I've extracted here. I'm passing on the email as well. I did say to you that when you create a user pool, you can control what various attributes the user needs to supply when they register. Now, in my user pool, the only additional attribute was email, but you could have many others. So here I'm just telling it what are the additional attributes, email, and I'm giving it the actual value of the email. This here is essentially the client that I had to create for my user pool. Okay, so what this here is essentially a reference to this here. Right, so I've created an instance of that object, and here I go. I create an instance of the command, and I send that command to send it to the Cognito client, which unwraps it and sends the appropriate HTTP request to the actual Cognito service. And I get back hopefully a successful response. So whatever response comes back from Cognito, that's what's sent back to me. So that's, in one sense, that's pretty straightforward. Extract stuff from the body of the event, create your relevant Cognito command, send the command to the client, and take the response back, and just send the response straight back to the user. In the case of the confirmation, which you saw me doing, in the confirmation, it's also a post request, and you have to specify the username, because Cognito at this stage has an entry in its database for this user, and it knows what code it sent out to the user as the confirmation code. So I'm posting that to a particular URL, and I get back a particular response. So the Lambda that's handling this request, okay, that's all right. Here's the Lambda that handles that particular request. And again, the flow is quite similar. Create a Cognito client instance, extract the relevant parts of the body of the request, and create the appropriate Cognito command. So in this case, looks like it's a confirm sign up command, which makes sense. Again, I have to specify the Cognito client that I'm using and the data that was entered by the user. Send it on and take the response and send it back to the client side, to the user, let's say. Right. As I say, when you walk through this lab and take a little bit more time to study the code, it'll all uh, make sense, I hope. So that's confirmation. So the user is registered now. Now they can actually log in or sign in. And I'm showing you the Lambda for a sign in this case. Let's just do a sign in. So again, I'm sending this request to the auth to the auth API, if you like, as opposed to the application API. This is the path name. And what I'm going to get back, assuming these credentials are valid, is what I want to get back is a JWT token, which I can then use to make requests to the app API as proof that I have logged in, I'm a legitimate user, and I can access the protected parts of the app. So it's the token that I'm looking for. So if I send this request, and we can see here, we're getting a token here, okay, in the response. Now, the way I've programmed this, the token is sent back as a cookie, and I need to send that token as a cookie for subsequent requests to the app API. And the app API will extract the token from the cookies. So I'm sending it via the cookie header as opposed to any other header, if you like. That's just an arbitrary decision that I've made. Now, with Postman, as you may know, if you send a request and there are cookies included in the response, then you can see the cookies by just clicking this link here on the top right. So if I select that, I can see that there was one cookie returned. The cookie's name was token. And if I just select that particular cookie, because there could be many, then this is the value of the cookie. And this is a JWT token, which you're familiar with from last year. So if I copy that, and again, given the way I've set up my collection here in Postman, I'm actually going to I've set a collection variable called token. This is just a convenience for me now. So I'm going to paste in the JWT token here. Now, just one little thing you need to be aware of at the very bottom of this is a timestamp. Is there a timestamp there? Let's keep going. Yeah. So you need to delete the timestamp part of the cookie. Otherwise, well, in the way that I've set this up anyway, the cookie will be rejected by AWS. So I just need to delete this timestamp part. Did I just mess up there? I'm just going to copy that now again because I think I might have messed up. Okay. Cookies in general, as you may know, cookies are key value pairs. So, and there may be more than one cookie that server side may return to the client. But in this case, it's only one cookie. The key is that, and the value is, as you can see. And if there are multiple cookies, then, they will be separated with colons. That's why there's a colon at the end of this here. Semicolon, sorry, is it? Semicolon looks like. Okay, so I've done that. And just something that I keep forgetting, make sure if you make any changes to a postman's collection variables, make sure you save them. Otherwise, they don't follow through. So now I'm going to do is sign in. And the way I've set it up is, okay, it's a post sign in. Oh, yeah, it's a post request again with my credentials. It's a post to the, sorry, I've already done sign in, sorry. No, the next thing I want to do is access a protected route. So I'm switching now down to the other API. As you can see here, I'm referencing the app URL in this case, as opposed to the auth URL. And I'm trying to access this route within, which based on its name, but anyway, it's also based on the configuration, which I need to show you. It's a protected route. I'll show you how to make routes protected in a little while. And I need to send my token, and I want to send it in the form of a cookie. This is it's a GET request in this case, just coincidentally. So there's no body. So you need to, in the params part of Postman, sorry, in the headers part of Postman, you need to add the cookie header yourselves. And you can see I've done it. It won't be in your case, so you're going to have to set it up. I've already set it up, obviously, for convenience. And in my cookie setup, you can see here I'm referring to the variable, the collection variable that I declared for myself. I call the collection variable token, as you noted there. So I'm just referring to that collection variable. And so that's fine, but I'm sending it as a cookie. Now, also, you do need these two other headers set as well. Otherwise, the validation of my token won't work. But I think I think these are actually almost enabled by default by Postman. But just make sure that they are enabled when eventually you get around to doing this lab. So I'm making a request. I'm sending a cookie with this request. The cookie contains my JWT token. And if I just send the request, do I need to do anything else? No, I don't think I do. If I send the request, then I'm getting back this response. And as confirmation that it worked, but I'll just suddenly out of nowhere, I'm going to just jump forward to the Lambda that was executed as a result of that request, my protected Lambda, Maria. So here's my protected Lambda. And it's meant to return this back to the client, and that's what I got in Postman. So it looked like it got through successfully. And just to prove that it is doing the validation of the token, if I go back to the Cognito, and if I just mess up the token intentionally, okay, so I'm just going to do that, and now try and make sure I save it first. Okay, so I'm getting back a authentication error. So there is something happening on the server side that's checking the token for me. Right, back to my slides. Okay, this is the Lambda that's executed when you sign up. And again, it's much the same, I think, as before. Extract the relevant parts of the post request, create the appropriate command object. Now, there isn't, oddly enough, there isn't a sign in command object. Instead, it's called the initialize authentication command, I think, is it? Yeah, initialize authentication command. Because remember, there are different authentication flows. Okay, and we configured the authentication flow when we created our. Not so much when we created our Cognito user pool, but when we created the client for that. Anyway, it's just a slightly different command. So I create my command instance. I'm configuring it. Again, I have to tell it what, I have to give it the ID of the Cognito client. And what else am I giving it? I do need to tell it, I do need to tell it what authentication flow this particular command should follow. Okay, so that's kind of reinforcing the fact now that it's the user password authentication flow. Obviously, there are other options available to us here. And other than that, then I'm just passing in the usual stuff, my username and password. And I send that to my Cognito client, which passes it on to the Cognito service. The Cognito service presumably verifies these two. And if it's happy, it generates a token and sends it back to me. Sends it back to this Lambda. And here you can see I'm, what am I doing? I'm extracting one particular part of the response that comes back. And within that, there will be my token. So now I eventually have a reference to my token, and I'm sending that back in the response. I'm sending it back in the response. Let's see. I'm sending it back in the response here, and we saw that, but also critically, I'm actually including it as a cookie. This is where I set the cookie in the response that comes back, that goes back to Postman in my case. But we saw as well, I didn't have to, but I included it in the HTTP response, as well as the HTTP response body, as well as including it in as a cookie. So I didn't have to do both of them, but I just did. Sign and request response, that's okay. I've demonstrated that to you. And I've demonstrated that as well. I've shown you where you can access the cookie and then the token within the cookie. If you want to, you can actually take the full text, if you like, of the JWT token. And if you go to this website and paste in the token, what the website will do is it will use the appropriate algorithm to decrypt the token, which I've done. And if you look very closely inside in the decrypted form of the token, you can see that it contains actually the username that I was using when I logged in. So that's part of what's contained inside in the JWT token. So that means every time I now subsequently send this token in a request to the app API, it will in turn decrypt it, look to see, does it contain a username that's a valid username within my user pool? And that's essentially how it verifies whether it's a legitimate token or not. That's just by the way. Okay, I think that what I intended to do here was show you now this part of the whole process, and I've demonstrated that really. I've tried to access the protected route. So my request was sent to a particular URL that happened to be a GET request, but that was coincidental. But critically, the request headers included a cookie header, and within that cookie was my token. That token then was sent to by API Gateway. I do have to configure API Gateway to tell it to consult with this Lambda first before you pass the request on to the relevant backend application Lambda. First, check with this Lambda that the token is legitimate. And this Lambda extracts the token from the cookies. So it needs to know that the token is contained inside the cookie headers. It extracts it, decrypts it, talks to Cognito. And if it's happy, then what it does is it creates on the fly an IAM policy that essentially says to API Gateway, you can now invoke the Lambda. Alternatively, it will create an IAM policy on the fly that says that denies it the right to invoke the backend Lambda. The code for this Lambda it's heavy enough going. You don't really need to understand it line by line, but I'm giving you the code and it will just work for you. So you will need to use this Lambda as well in the assignment, for example, but you can just simply reuse the Lambda that I give you. And as long as you understand how this whole flow works, then that's all you will need to know for the assignment. You won't have to go making any changes to this Lambda in the assignment. This is let's see, what am I showing you here? I'm showing you, okay. So this is some of the CDK code for the app API. Again, if I go back, it's for this API here. I haven't shown you any code for this API, but it's actually straightforward. It's the exact same as the API that you are developing in the labs. The fact that it's performing authentication is not really reflected at all in any configuration of this API gateway. The Lambdas obviously are unique, and I've shown you excerpts from some of those Lambdas already. But how you configure this API gateway, there are one or two little things that you need to do. In particular, you need to sort of make this connection here. That's part of the configuration. So that's what I think I want to show you here. So I'm just creating an API, a REST API, as you did in the labs. I'm adding the protected route, the protected path, sorry, and I'm just attaching it to the root path. I'm also creating a public path, which is also connected to the root. What's next? I have a Lambda function. I've got a Lambda for both as the backend for both of those routes, and we don't really care about the internals of this Lambda. The Lambdas are actually pretty straightforward. They're one-liners. One of them returns, just showed you, for example, the Lambda behind this protected route there a moment ago. You know, that's it. Just returns a response as proof that the request got through to the Lambda, and the public one is similar, just as a one-liner. So we needn't really care about that. Now here's where it's the authorizer kind of comes in. So I'm creating another Lambda, a third Lambda, and I've labeled it the authorizer function Lambda. I'll show you the code. Well, sorry, I'm not going to. I'm giving you the code. I'll just I have already kind of explained what the code does, and I think I have a screenshot. I have a slide that sort of explains what the this Lambda does in English rather than looking at the raw code, because the raw code uses a lot of third-party functionality, okay, which we can kind of conveniently ignore in a sense. But how to connect this Lambda with my API gateway and tell the API gateway that this particular Lambda performs the role of the authorizer, that's what's going on here. So you have to create, in CDK terms, you create an instance of this request authorizer and configure it. And the configuration includes, let's see, it includes, you have to say, well, how is requests that come in from Postman, how do they, or where do they declare the credentials of the user, which in our case is a JWT token. And essentially we're telling it that the token will actually be contained as a cookie. That's what the purpose of this setting is. The handler, which is just a reference to the Lambda function that actually performs the authorization check. And I'm just deciding that I'm not going to go caching anything for subsequent requests. That's just an arbitrary decision again. So that creates, that's, if you like, this is a kind of a wrapper for my authorizer function. And then I connect this guy to my API gateway, and that's what I'm doing. And I connect it to particular routes of my API gateway. And that looks like what I'm doing here. Let me just check again. Yeah. So I'm saying I'm taking the predicted route, which I've protected route, yeah, which I declared up here. I'm adding a method to it. That's all right. It's a get method. And it's this line here is what actually makes that particular method of that particular route one, is what makes it protected, because it has to go through the authorizer before it can actually be invoked. So that what I've just encircled there, that is the key kind of hook in my API gateway configuration that makes a particular route protected or public. Authorization type. Okay, I'm setting the authorization type as being custom. I'm defining it myself. There are inbuilt authorization settings that you can have, but I went for the custom one. Right, there's a lot going on there now, admittedly. And I have shown you that, demonstrated that, so you do need to set various headers in any request to the app API, any request that requires authentication. Those that don't require authentication, you can leave out the cookie completely. This is essentially the steps performed by the authorizer Lambda, and it's predictable enough, right? It essentially needs to extract the particular cookie and the particular cookie, in our case, we called it the token cookie. It extracts that from all of the cookies that might come with a request, because again, a request may have more than one cookie. So it's just extracting the one that it's interested in. What it's doing is it takes all the cookies and it puts them into a map data structure. And then from where the keys in the map are the keys of the various cookies. So this map that it has created contains a number of entries. Potentially, in our case, it will only have one entry where the key is token and the value is the actual JWT token. So now it has the token, and if there is no token, then it'll automatically return an it'll return an IAM policy that denies access to the protected Lambda. This authorizer won't be invoked at all if a particular route has not been declared as being protected. And the way we declare a route as being protected is what we did here. Okay, so the public route that I have won't have a setting for this, so it never goes near the authorizer, the authorized in the case of the public one. So if there is no cookie, if there is no token at all, then obviously deny access. If there is a JWT token, then go through a verification step, and that's just a method call, right? And the method is provided to us by AWS SDK. So, we just invoke the method with the appropriate parameters. And if the method returns successfully, then we know it's a valid cookie. We know it's a valid JWT token, sorry. In which case it creates an IAM policy that allows the API gateway to call the Lambda. Otherwise, it creates an IAM policy that denies access to the backend Lambda. Just I'm almost reluctant to look at the authorizer, but like here it is here. And it's using, if I just leave that open, it's using utility functions down here as well. And there's only one thing I want to show you really here, which is this create policy. So this is the function within the code that I've talked about there that creates the IAM policy. And you're kind of vaguely familiar with IAM policies from last year, but here's an example of an IAM policy. Okay, that's the outline of the policy. This method is called with, let's see, it's called with a string, which is either going to be allow or deny, and it's also called with, let's see, what's the purpose of that now? API gateway authorizer event. Let's see. Maybe if I go back one step. Yeah, let's, if I just open up this one for a second. So this is the Lambda that's invoked. Let's see, this is the Lambda that's invoked when a user tries to sign in. Yeah. And it's very like the Lambdas that you've been developing in this week's lab. And in particular, the type of the Lambda handler is this, right? API Gateway Proxy Handler version 2. They are the same as the handlers that ye are developing in this week's lab. So I would describe them as standard API Lambda handlers. Okay. However, the authorizer is a different type of handler, as is evidenced by this. Okay. It's just a different type of handler. That's the only point. We don't have to worry about the nitty-gritty of what's the difference between this type of handler and the other. They are different handlers. So this Lambda that I'm showing you here, this Lambda is not one that's invoked by API Gateway in the normal way. What does he mean by the normal way? Well, the Lambdas that are over here, they're what I'm calling Lambdas that are invoked in the normal way by API Gateway, in the sense that it forwards requests onto those Lambdas. These Lambdas, the handlers are of type API Gateway Proxy Handler. This is also a Lambda that's invoked by API Gateway, but it's not the normal kind of invocation. And that's why the type of this Lambda is different from the type of the Lambdas that are over here. And indeed, these Lambdas here are the exact same type as the Lambdas here. They're invoked in the normal way, in the normal kind of request response flow. This one is different. So the reason I mentioned that is because the event that this handler receives might be structured slightly different from the event that the other handlers receive. And I am passing that event down to that function that I was talking about here, the one that creates the IAM policy. Looks like I'm passing that event. Can't remember exactly why I'm passing that event. Do I use it? Oh yeah, the only thing I'm using it for is here. I'm just extracting the method of the request that came from Postman, whether there was a get or a put or a post. Okay, so the policy seems to be specific to the nature of the method that was invoked. I don't think that's actually that important. What is important is whatever this is going to be set to, whether it's going to be set to allow or deny. And this function is called by my authorizer. Let's see. You can see here, for example, it's calling it, and it's calling it with a deny as the effect of the policy. And that looks like in the case where there was no cookie supplied with the request, in which case there's no JWT token. So we want to deny access to the backend Lambda. Here's another case. I know now I haven't really stepped through the code of the authorizer because I'm inclined to just not want to do it because we don't need to get into the nitty-gritty of it. Create policy. Here I seem to be checking to see, well, here is where I'm actually verifying that the token, whether the token was valid or not, and depending on whether that's a true or false, that determines whether I set the effect of the policy to be allow or deny, and so on. Right. In conclusion, I will say that I think when you walk through the first lab when we come back, which is effectively to produce all of this stuff here, then certainly the whole sign up, confirmation, login, that sequence of steps will be clearer to you. It may already be clear, but it'll be a lot clearer to you. The authorizer will become clearer when you walk your way through the lab. So I'm just kind of really leave it at that, really. I will pause for a minute just in case there are any obvious parts to this jigsaw that I haven't explained to you. No. Okay. In that case, I want to, let's see. Yeah. I'm just going to park that. So in that case, so we've looked at a number of AWS serverless services, that being the Lambda service, the API gateway service, the DynamoDB service. In fact, if we go back to this one with a nice kind of one at the beginning of Cognito. Yeah, we've looked at this service, which is the serverless compute service. We've looked at these two states-related services, and we've looked at API gateway and the communications serverless service. Okay, we will also look at SQS and SNS later on in this module, not under the heading of serverless, even though they are serverless. But as I said there at the beginning of the lecture, these two services predate the whole notion of serverless, so they've been around for quite a while. But they are critical, actually, in the implementation of a serverless application. Anyway, so that's for later. What I'm going to do next is jump over to the assignment specification. Which is here. By the way, I've also, you may or may not have noticed on Moodle, there's an assignment 2 and there's a link here to a specification, but if you click on that, you don't get anything. That's only there for our external examiners, so you needn't worry about that. Although I will put some text behind, I will put some text here, maybe over the midterm break. But again, it's not really aimed at ye, it's more at what we call our external examiners, which are academic people that look at the various assessments that we set for students to see whether they're appropriate and all that kind of stuff. Anyway, this is the one that we are interested in. And I would say, if you have read it, then you will notice that this assignment is really based on what you are doing in this week's lab. And it's taking that whole notion of a RESTful web API and building out a one for yourselves based on a particular context. And I give you the context. I'm just sticking with movies for no particular reason. So you've got to develop a RESTful web API that allows users to access movie reviews and post movie reviews, and also update movie reviews. To add a review or to update a review, you must first authenticate. And when we're not getting into the nitty-gritty of whether it's your review or not, you can update any review, provided you know the ID of the movie and the name of the reviewer, right? So there is no checking to see, are you the same person? We could build that in, and you can if you want to build that in. But make sure you make me aware of that so that I can give you marks for that, but it's not built into the specification. So you need to obviously write the CDK code that creates the various infrastructure, which will be API Gateway, Lambdas, DynamoDB. I suggest that you follow the exact same. I'll put it stronger to suggest you must follow the exact same architecture that we've just been talking about, which is, in other words, this architecture. So you'll have an auth, and you can pretty much take the code that I give you in the next lab. You can pretty much take that and reuse all of that for yourselves. So that's for free. Okay, the stuff down here is what's going to be unique to you, but you obviously have to kind of link them all together. So that's why I'm saying the serverless is. I'm saying it's a secure serverless REST API. By robust, I mean there should be appropriate validation carried out in the Lambdas. And you've got examples of how we do validation in our Lambdas, certainly for a post request or for a request that includes a query string. So you know how to write code to do that. And I've given you a third-party library, that AJ, what was it called? AJV library, to carry out your validation. Okay, the completion date is, I'm setting it as roughly a month from now. It's worth 40%. What you'll submit is the URL of your GitHub repo, and you'll also make a YouTube video demonstrating your working REST API, presumably using Postman. I'll talk a little bit more about what should go into the YouTube video, maybe when it comes closer to the time. There will need to be a README with your GitHub repo, and I will give you a template for that. As you should know by now that I have a hang up with Git and having a Git log on your GitHub repo. So it's really important that there is a Git log of all of the work that you've been doing on this assignment, and I would expect that Git log to span out over the time period between now and when the hand update is, and make sure your Git commit messages are a clear statement of what you were doing between two successive commits. So pay a lot of attention to that, because that's going to be really important for me, as well as obviously the workings of your application. And then I'm giving you here a detailed breakdown of the various endpoints. So I'm being very specific as to what I want you to develop. And so if I just go through them, I suppose, so a post to /movies/reviews is how you upload a review to our movie database. There's going to be one table, just movie reviews table, and I'll show you the structure of the table later on in the specification. So I do want everybody to use that exact path name. And sorry, now just give me 1 second. Post movie reviews. Oh yeah, that's okay. The next one is for getting all the reviews for a movie. So this is a parameterized URL. Here's the parameter within the URL. So that should return all of the reviews for a particular movie. And you can just, just put them into it'll just be an array of JSON objects. Yeah. So that's straightforward enough as well, I think. Let's see, do I say anything here? The third one is, it's the same URL as the second one, but we're allowing this additional query string part. So we're narrowing down. We don't want all of the reviews for a movie. We want only those that have a particular rating. So rating must be one of the properties or the attributes that are stored in my database. Now, because both of these have the same URL, it's the same URL here as the one just above it, then that means it's going to be the same Lambda that's dealing with both of those requests. I'm hoping you will deduce that. So within that Lambda, you'll have to check to see whether there is actually a query string or not, and that will dictate whether you return all the reviews or just some of them. Next, we have a request for a particular review written by a particular reviewer. So again, one of the attributes in a review item will be the reviewer's name, and let's say it's a username type as opposed to their full name. And again, you can just make up reviewer names, but it's kind of username format, let's say. So this should only return one review. So the combination of movie ID and reviewer name, that is going to be unique. Same person isn't going to write more than one review. So I'll just return one review. This one is if you want to update a review. So it's a put in this case. And the URL looks similar. It is actually the same as the one above it, but it's obviously going to be a different Lambda because it's performing an update. That's provided there is a matching review. There may not be. That's an example of the robustness that I was talking about. But either way, it allows you, and it'll just be an update operation on your DynamoDB table item, although you have to find out how to do updates. I didn't cover that in the labs. Next one is get movie ID /review/year. So this is meant to return all of the reviews for a movie that were written in a particular year. And we'll see later on how we can extract those from the table. So it's different. It's a different URL. Well, sorry, let's see. It's not really a different URL to this one here. Okay, it's essentially the same URL as that one, except the parameter. So there's two parameters in the URL that I just highlighted there. There's the movie ID and there's the reviewer name. Equally down here, there are two parameters, movie ID and year. But in terms of kind of string matching, if you like, they're essentially the same strings. So from API Gateway's point of view, it cannot make a distinction between that URL and this URL. It can't do that. So it's actually going to route it to the same Lambda. And so within that Lambda, you're going to have to work out, well, is the second parameter within the URL, is it a year or is it a reviewer's name? I'll talk a little bit about how you might do that in a while. Moving on, get movies /reviews /reviewer name. Get movies /reviews /reviewer name. So that's meant to return all the reviews written by a reviewer. Okay, that's probably going to be a scan operation on your DynamoDB, but more than likely. But you can work that out for yourselves. Next one, I'm not sure if this is really helpful now, me stepping through this, but I'll keep going anyway. Get /movies /movie ID /reviews /reviewer name /translate, and then a query string part. So the purpose of this endpoint is to return a particular review, because again, it's movie ID. We're specifying a movie ID and we're specifying a reviewer name. So that's going to match one review in my table. But what I want the Lambda to do is to translate the review. And I do say later on that let's assume all the reviews are written in English, but it's going to translate the review into another language and return the translated version of the review. And the language it translates it into is specified as the query string here. Now, that will involve, and that's quite complicated now, that will involve using a service called the AWS Translation Service, which is essentially an AI service, one of the number of AI services that is available now on the AWS platform. So it'll take a bit of work to get that going. It's a different Lambda that's going to be taking care of this, because the /translation part within the path distinguishes it from any of the other earlier paths that didn't have a /translation part to it. So we can route it to a particular Lambda, but that Lambda then will first of all check to see, well, was there a query string included? And if there wasn't, then I guess it could return just the review that it found within the database without doing any translation. If there is it the language? Is the query string contain the language key? If it's not, then it should return an error, I guess, saying the structure of the query string is incorrect. If the language is there, then it'll use the code. And the code is dictated by the AWS Translate. When you read up on that AWS Translate service, you'll see that there's quite a wide range of codes. You could just maybe deal with a small subset of them. So to get that working now would require a significant amount of work on your part. And hence, in my grading spectrum, it's up at the top grading spectrum. Right, so there are all the endpoints that I want you to support. And you don't have to support any ones outside of those. I'm saying that there needs to be an authentication part to this assignment, and that is essentially means, you should have, this top part as well plugged into your overall infrastructure. But as I've already said, you can essentially take the code that I give you in the next lab that you're going to be doing and reuse all of that. But just plug it into your infrastructure. In terms of authorization, I'm saying that it's only put and post requests that are essentially protected routes. And you can look at the list that up above as to see which of those, which of the various endpoints that I've specified up above there involve put and post. I think there are only two of them actually. Most of them are get. But the put and post ones have to be protected. And again, when you walk through the next lab, I've already tried to explain it in this lecture, but you'll get a better understanding when you've completed the lab as to how you actually make a particular endpoint protected. So without laboring the points, that will mean now that, we'll be sending our JWT token as a cookie for the put and post requests and so on and so forth. Here, I'm just briefly talking about the translation or translate service that is available on the AWS platform. And I give you a link to this text here. I've just taken straight out of the docs, but I've given you a link to the docs and you probably should read a little bit more about it. I've also given you a link to a video. I've given you a link to a video demonstrating how to actually use the translate service in a Lambda, which actually is also written in TypeScript. Lambdas can be written in any language, as you know. So it might be worthwhile watching that video. It's only about 20-25 minutes. Certainly will be of help to you. I don't think the person that's doing the demonstration is using the CDK, but they do show you, and I'm pretty sure there's a GitHub repo accompanying the video. So I didn't check to see whether that repo is still there or not, but it may well be. So you'll have a certain amount of code that you can play with and maybe reuse. On the DynamoDB side, there will only be one table, okay? It'll be the table that has our movie reviews. And these are the attributes of each item in that table. And surprise, surprise, movie ID is going to be an attribute. I am telling you that is the partition key, or you should use that as the partition key. Reviewer name, think username. And it does not have to be linked to the user pool in any way. Okay, I've relieved you of that kind of cross-checking. The review date. Now, the date, I'm saying, I'm restricting it to this format. So the dates have to be in this format: year, month, day. And they are strings, though. We don't have the luxury of a date type built into DynamoDB. And this is relevant now because one of our endpoints was where we wanted to retrieve all of the reviews for a particular movie that were written in a particular year. So we know now that the year is going to be the first four characters in that string. Okay, I'll just leave it at that, right? And finally, the text of the review. I've already mentioned, or do I say it here? I think I maybe say it here, but I've already mentioned it. I'm saying, I don't mention it here actually, I think, but I say that, and it makes sense that there would not be more than one review written by the same reviewer for the same movie. I mean, we'd assume that anyway, I guess. But in addition, I'm telling you here, and this additional piece of information is very relevant. I'm not saying, is it here? I'm saying it. Oh yeah, it's here. I'm saying it. I'm also saying that you can assume that there will not be more than 2 reviews for the same movie with the same date. So, okay, you can assume that. In real life, that wouldn't be a very sensible assumption, but you can assume that. So the review date, movie ID combination, they are going to be unique. You're never going to have 2 items in this table with the same movie ID review date combination. Equally, you're never going to have the same, you're never going to have two items with the same movie ID and reviewer name combination. Okay, so that information is important. I will put it no more than that to you. I'm also saying here, look, I'm not telling you anything about the design. I'm not telling you anything other than telling you what the partition key is. I'm not telling you anything else about the design of your table. And you'll have to try and glean what I'm trying to get at there without me saying what I'm trying to get at there. Right, all a bit vague. Grading. So this is how I decided, came up with my grading spectrum. So if you've got quite a number of the GET requests working and the POST request, adding a new review, then you fall into the 40 to 55 grade. So, you know, to be within the 40 to 55, you can essentially ignore all the authentication stuff. But just get most of the sorry, no, I'm saying, just give me 1 second. Oh yeah, I'm talking about lambda A, B, and C here, but lambda A, B, and C are actually referred to down here. So I'll come on to that in a second. So that's the good grade anyway, 40 to 55 in what I'm calling the excellent grade, 55 to 75. So that's quite a wide band, really. You'd have to have all of the endpoints working, except the translation endpoint. And you'd have to have the Cognitor stuff built into it as well. And then for the top grade band, then all of the above, obviously, plus you have the translation endpoint working. And as well, I'm imposing some other requirements on you, because to get into this kind of grade band, you kind of have to demonstrate that you are an independent learner. I'm asking you to either utilize what are called Lambda layers in your CDK stack, or utilize what are called multi-stack apps in your CDK code. So you would have to read up on both of these, decide which one you're going to go for, and follow through on that in your CDK code. So these are all at the CDK level. The general explanation of Lambda layers is each Lambda function is packaged and sent up to the AWS platform as a standalone entity. And they're all deployed separately, as we know. Each Lambda function deployment includes all of the node modules in your application, all of them. So each Lambda has a copy of all of the development dependencies, all of the dependencies, not the development dependencies. In other words, in terms of the package.json, if I flip over to package.json, here. So all the dependencies that you have listed here, they are all included with each Lambda deployment. Now, clearly, there's a lot of replication going on there. It would be better if we could put all of the dependencies into a separate deployable unit, and each of the Lambda functions deployment would just be the Lambda functions code, and it would somehow refer to this other unit that contains all the node modules somehow. Now, putting all of the dependencies, node module dependencies, into a separate unit, we refer to that unit as a Lambda layer. And so in your CDK code, you would have to say, I want to include a Lambda layer, in my CDK deployment and associate the Lambda layer with the various Lambda functions. So you'd have to see how to code that at the CDK level. This is purely a CDK issue. It doesn't affect your implementation of your Lambda functions at all. So it has no effect on the actual code that you write. It doesn't affect the Lambda function code that you write. It obviously does affect the CDK code that you write. That's Lambda layers. The other thing I mentioned was multi-stack apps. The only type of app that we this is app in the CDK sense now, the only type of CDK app that we have dealt with is a single stack app. But for very large apps, it might make sense to break it up into multiple stacks. And so what I'm asking you to do is to try and achieve that. Now, deciding what should go into each stack, that's part of the challenge. But if you read up a little bit about it, there are some fairly standard patterns to follow when you're trying to implement a multi-stack app. So first of all, read up on what are multi-stack apps, then read up a little bit on what's a typical way of breaking up an application's overall CDK stack into multiple stacks. And then thirdly, well, how do I actually write the CDK code to achieve that? Neither of them, the Lambda layer and the multi-stack idea, neither of them requires a lot of changes to your CDK code. But maybe that's easy for me to say. Either way, I guess you wouldn't be addressing either of those issues until you had already managed to, implement pretty much all of the functionality, first of all. So I wouldn't go reading up on Lambda layers and multi-stack apps for quite a while yet. The last thing I've done in the specification, I don't know whether it will be useful to you or not, is I'm actually giving you, or I'm proposing a strategy that you might follow in terms of how you tackle this specification. Obviously, you take an iterative approach. You get certain part of it working, and then you move on and get more of it working, et cetera, et cetera. We don't take a big bang approach. We kind of take an incremental approach. And the nice thing about CDK is that once we write a part of our code, we can just see, does it deploy? And then does it work in terms of from a Postman point of view? And if it does, great. Then you move on and add some more functionality, add some more infrastructure, redeploy, and on you go. So I'm proposing this strategy here. You don't have to follow it, but makes a certain amount of sense to me anyway. Maybe the very first thing you should do from a CDK point of view is just get a stack that consists of your DynamoDB table and the seeding of your table. Now, I've shown you how to seed a table in the labs. And so all you've got to do from this assignment point of view is decide on the design of your DynamoDB table in terms of partition key, primary key, secondary indices if they need them. Don't know if it does or not. And just get that working and deploy that. Then move on to your REST API and start off with just one endpoint. And I'm saying maybe just start with the simplest one for your REST API, just the one that gets all of the reviews for a particular movie. That's what I'm saying here. Okay. And so that's this. So you're now adding your API gateway. That's the API gateway, the app API gateway, as opposed to the auth one. And you're going to have one Lambda. And I've just arbitrarily called this Lambda A. Okay. Get that working. Test it with Postman. Next, move on to another endpoint. And I'm saying, let's pick the one that allows me to add a review. So that means I'm going to create another Lambda function to handle that request. I need to extend my API gateway, the app API gateway, to accept those requests, get that working. This is a second Lambda now, so I've got two Lambdas, which I'm just arbitrarily called Lambda A and Lambda B. Let's move on. Let's extend Lambda A. So Lambda A is the one that accepts a GET request for all reviews for a particular movie. But I'm saying extend it to allow for the query string part. And the query string part was where I specify, sorry, I've just thought of something now, actually. Can I just go back for 1 second? Yeah, I've actually left, I must update this. I've left one attribute out of this list. We have to have the rating attribute, which will just be a numeric attribute. Apologies about that. Okay, so we're going to have another rating attribute in this list here, and it'll just be numeric value. So back to my strategy. My strategy, I'm on to step 3, and I'm extending Lambda A. Lambda A is the one that just accepts a GET request for all reviews for a particular movie. But now we're adding on the query string. Sorry, this one. Yeah, this one here, sorry. We're adding on the query string possibility. So that means I need to change my Lambda A to check for such that it's checking to see, is there a query string part in the request? And then respond accordingly. And if there is a query string, but it's not structured correctly, then I guess return an error response and so on. I don't know if I'm going to really talk my way through all of these now. You can see what I'm trying to get at here, just getting you to take an incremental approach towards completing this assignment. And I'm giving labels to the lambdas. I think there's up to the last one, I think, is lambda D, lambda E. Okay, and the reason I gave those labels to them is related back to the grading spectrum, because you can see in the grading spectrum, I'm saying, look, for this particular grade band, you need only be concerned with lambda. Sorry, no. For this grade band, you need only be concerned with lambda A, B, and C. Okay, and A, B, and C then are mentioned below as to what A, B, and C refer to. Okay, do I need to? No, I don't think I'm going to talk my way through those now, because that's not very entertaining, I don't think. There's one last thing that I want to talk about, which is, if I go back to, sorry, just give me 1 second now. Yeah. If I go back to here, and it's this whole area of dates, all right? So, sorry, now let me go. Okay, so we said the review date has to have this, has to be like this. So I guess that would mean when we add a new review, I guess inside in the Lambda that's handling that request, it should really check that the date provided by the user, is structured properly. Otherwise, the whole thing kind of messes up really, because we've got a number, one of our GET requests is about returning all of the reviews for a particular year. So, if the dates that are stored in the tables are not following this pattern, then we're in trouble really. So how do we actually check? Because this is just a string, it's going to be just a string in a post request. How do we check that the string is structured correctly? And the answer to that is to use what are called regular expressions. Regular expressions, I don't know if you've come across them in any of the coding that you've done up to now and the programming that you've done up to now. It's not a TypeScript thing. It's not a Lambda thing. It's not an AWS thing. Regular expressions are a programming technique, but which is supported in all languages. But the question is, how is it supported in TypeScript? And so what I've done is just giving you an illustration. I don't want you to necessarily spend time, although it wouldn't be wasted time, to read up on regular expressions. But if I just show you some code, and you can actually, I'll post the code up on Slack and you can reuse it. So if I quickly load the code. So to use this regular expression technique, first of all, you have to declare a regular expression instance, and you then compare that regular expression to a string to see if the string follows the particular pattern that you're looking for. So it's all about this pattern matching idea. I may well, okay with time actually. Okay, so in TypeScript, there is a type called regex that's just built into the language. So it looks like I'm declaring a regular expression variable here. And the way you initialize it is it begins with a slash and ends with a slash, and everything in between then is regular expression syntax. Now, you could spend time reading up on regular expression syntax, and it certainly wouldn't be wasted time, but I'm not teaching you regular expressions here now. So what this regular expression is saying is it's looking for the pattern in the string where the string begins with the caret symbol there at the beginning of it means it begins with either the characters 1 9 or 2 0, as in 19 something or 20 something, followed by 2 digits. So that's this is a way of validating that a string contains a year in its assignment. Okay. So for example, if I declare this variable here called year and I assign it 1999, and then I test to see, does this variable match the pattern that I've defined here? And when I do a console log, and the way you do the test is you invoke the test method on the pattern and you pass it the variable that you're testing or checking. So this expression, year format dot test year variable, that should return a true, because it certainly looks like that does match what I'm looking for up here, as in it does begin with 1 9, and the 1 9 is followed by 2 digits. Equally, this one should satisfy the criteria, whereas this should fail because there's a Y. Sorry, what I didn't say there was the dollar symbol there at the end of the pattern is saying that it's specifying what the end of the string is. The carets is specifying the beginning of the string. The dollar is specifying the end of the string. And when my pattern has both a caret symbol and a dollar symbol, then I am essentially telling it what should be at the beginning and what should be at the end. In other words, what I'm telling you here is this: my entire string can only contain a year value in it. It can't contain anything else. But this one violates it because it has a Y at the end of it. So that should fail, and certainly that should fail. So I got 4 console.logs, and if I run this little piece of code, then it should confirm that the pattern that I've defined and on line 1 there is working. And so to run it is npx Okay, so you can see true, true, false, false. That's what I expected. My second example of a regular expression is this one here. And this is far more involved. You can see the regular expression is extremely long. Where I got this from actually is a post online, and I'll put the URL of that post up on Slack, and you can read it yourselves. But what this is checking for is essentially it's checking that a string matches this date format that I've specified for the assignment. Okay. And you can, as I said, I'll post this code up on Slack, so you can certainly use it if you want to in your assignment. And I'm testing it then again. I'm not going to talk my way through the regular expression now. I don't have time, but this looks like it's a valid date. This looks like it's a valid date. This one is not a valid date because 18 is not a valid month. And this one certainly isn't a valid date. And you can see when I ran it down here anyway, that I got true, true, false, false. So it looks like that the regular expression that I defined here seems to be doing the trick for me. And equally, you may find that useful for the assignment. Okay, I'm out of time. I will accept any questions if there are any questions, if you're still there. Are there any questions? No, okay. I'll leave it at that so for now, and I will talk to you a week after next. Enjoy the midterm break. Bye-bye.